Hello everyone, welcome to my channel. Today I'm gonna go over a very interesting topic that relate to all engineers who work in the manufacture, which is cavitation. Cavitation is a common issue that face engineer when they handling centrifugal pump. And as you know, centrifugal pump is used in so many locations. Might be domestic, might be oil and gas plants, might be water treatment plants. So let's get started. Um, so first, we need to know what is a centrifugal pump. Centrifugal pump is a mechanical device. It's responsible for moving fluids from point A to point B through a piping system. And of course, we all know the centrifugal pump as the main part or the heart of the pump, which is the impeller, which is responsible for increasing the velocity of fluid and the pressure as well. And the application of the centrifugal pump used domestic, used in a chemical processing, used oil and gas plants, and used in anywhere, maybe hospital, residential, and everywhere. So let's go to the main topic of today, which is cavitation. So what is the cavitation? Cavitation is the formation of bubbles, vapor bubbles in a suction line due to lower pressure. And the centrifugal pump and the pump in general is only designed to handle liquids, not gas. So in case we got like a vapor or a bubble, these bubbles work against the impeller and is gonna hit the impeller plates while it's rotating and lower the lifespan and make to and lead to deterioration of the plate itself, which will lead to lower the lifespan, maybe lead to shut down the equipment, and may at the end uh, replacement the pump itself. So whenever the cause of this, it happens when the pressure of the pump is low, and of course the liquid is vaporized. Um, this is how it looks like here inside the impeller. You see like about like erosion of the plate itself, and a pitting. It sounds like as a corrosion, but it's not corrosion. Is a kind of pitting, or is that related? It is not a pitting or a corrosion, but is the effect of hitting the bubbles or the vapor bubbles to the plates of the impeller. How does this happen in the pump? Three things. First, lower inlet pressure in the suction line. That's lead to the liquid to evaporate, and that's hit the impeller as we discussed in the previous slides. And also the high flow rate, which means high velocity, and according to Bernoulli equation, high velocity lead to low pressure, and low pressure means there the bubbles can be freed and hit the plates of the impeller, which cause the cavitation, of course. And of course, the temperature influence by default. If you have a high temperature, that's mean the liquid is gonna get energy to evaporate and lead to cavitation as well. So what's the consequences of the cavitations? Of course, damage of equipment. Um, as we saw in the previous slides, kind like a pitting here, or erosion. Erosion due to mechanical action. Corrosion related to a chemical action or a chemical reaction between the surface and the liquid, but in this case, related to erosion is a mechanical action because there is no chemical reaction happen at all. Um, Also, the performance, if you check the HQ curve, you'll find the performances get lower because the capacity will be lower. The lifespan, of course, of of the pump will be lowered and might be need to replacement eventually, and the higher fixed cost of the pump as well. Of course, you will hear like a vibration and weird noise coming out from the pump, and um, and the pump is gonna failure to pump in liquid, and it will be stopped. So now we know like what is the cavitation, what is the pump, what's the consequences, how is it affecting on the long run, uh, all this stuff. How we prevent this? So in order to prevent this, we need to know very important term called net positive suction head. So basically, net positive suction head is the absolute pressure in a suction line should be higher than the vapor pressure of liquid to keep the fluid, to keep the liquid in the liquid state without vaporizing. That's basically what is net positive suction head. So it has two types: net positive suction head available, which we can know it from the system design based on the pump size, the inlet pump of the suction, the size, um, the vapor pressure, what type of liquid you handling, water, you handling oil, you handling any kind of liquid. All these characteristics is affecting net positive suction head, and of course has a formula. Net positive suction head available, be atmospheric pressure plus suction pressure minus vapor pressure plus kinetic energy. And in order to keep the pump pumping without vaporization of the inlet liquid, it should be the net positive suction head available higher than net positive suction head required. So what's the net positive suction head required? The net positive suction head required, we know this from the manufacturer. So the manufacturer, every pump has like a manual or a curve, and based on the pump and the manufacturer itself, they do like kind of testing on the pump and give you like a net positive suction head required because not all the pump designed to handle any kind of fluid. So the high viscosity fluids has kind of pump, maybe a gear pump, whatever, and it depends on the applications. Maybe you need like a high flow rate and low pressure. Maybe you need a high pressure, low flow rate. So it depends on kind of pump itself. So so the required we get it from the manufacturer itself, and it should have like give you like a curve. Maybe I get it to you in next video. Has like a curve, and based on the curve, you can calculate the net positive suction head available by the formula, and you get the one by the manufacturer, and based on the operating condition, you know the net positive suction head if it's higher than this required net positive suction head required, so we can pump, so there is no vaporization happen. So I might get it, and I will get like a curves in next video to know more and more. And of course, net positive suction head required is a function of pump design, of course, and speed and impeller characteristics and fluid characteristics. So, and it means, the pressure required as a suction side to prevent cavitation. So how we avoid cavitation? So we know the main problem of cavitation is lowering the pressure. So we need to lower the pressure as much as possible. So there is some stuff in our hand we can do it to lower it. So first of all, if you liquid you're sucking from a tank, so we need to increase the head. So in this case, we're gonna increase the absolute pressure, and in this case, there is no possibility of the level for fluid um, to evaporate. And if possible, you can lower the pump itself from the source tank, so there is no much distance to for the liquid to evaporate. And reduce friction. Reduce friction suction line if possible. You get like kind of pipe that doesn't has too much friction. Not say like smooth, but there is no pipe is smooth 100%, but you can get kind of pipes that are lower friction, because as long as the pump, the fluid flowing inside the suction line, there's losing pressure. You get delta B, and the delta B means you losing pressure, and the pressure will be lower and lower, and in this case, the liquid will be evaporate and will cause cavitation. So if in this case you are not able to get like a pipe which is low friction, or you can make the pump itself very close to the source tank, so the liquid will not take much time to flow to the pump. So in this case, you lower evaporation of the liquid. Um, and of course, the fittings is playing very important role. So the more fittings in the suction line, the fittings is lower pressure and make losses and make the pressure to be dropped. And don't use the bends and elbows too much unless you need to. And if you need, you don't need too much. Um, what else? Also reduce the net post of suction head required. Is determined by the pump design. You have to do good selection. So the designer and before you pump something, you need to know what kind of pump needed. So in this case, maybe you see the chart from the manufacturer. According to you can lower the speed, and the speed if lower, the possibility of net positive suction head to be lowered as well to avoid cavitation. And also maybe use a booster pump, like two pumps in series. So in this case, you will increase the suction pressure. So in this case, lower possibility of losing, um, making the vapor to, making the bubble to evaporate. So yeah, this right now, I believe, like three common things you can do it to lower, um, to keep the cavitation at minimum. I believe I go over like a quick overview about the cavitation. And if you like this video, please hit like and share. And and thank you for watching. And see you next video. Bye bye.